Hi! In this video, we'll be going through a brief overview of the history of the computer. So before we can really look back into history and identify computers throughout history, we really need to answer the question, what exactly is a computer? What is the bare bones definition of a computer? So go ahead and take a moment, pause the video, and think to yourself, what exactly is a computer? What is your definition of a computer? When you think of a computer, what sort of things come to mind? So take a moment, think about that, and then continue the rest of the video. Great. So for me, when I think of computer, this is generally what I think of. I think of these modern, sleek devices that have all these fancy buttons and cool colors and can do these really awesome things. But what is it about these different devices that makes them a computer? What exactly is it about these things that make them computers? Well, really, at the core of it, a computer is just a computing machine that can perform calculations according to precise instructions. Computers are things that take in instructions and then perform mathematical and logical operations. That's really all they are. They're calculators with a lot of added benefits on top. And really, the only thing that separates a computer from a human is that it can do these operations incredibly fast. It's doing very simple mathematical operations. A second grader could do the mathematical operations that computers do. The only difference is that a computer can do it at lightning speed, millions, billions of times per second. In fact, the first definition of a computer was used to refer to a person. In 1613, the word computer was first used to describe a person who performed calculations or computations. So the first computers were people. It's only recently that we've taken this term and applied it to these computing machines that are actually rapidly carrying out these mathematical calculations. So with this definition of computers, let's look back in history and see where exactly computers came from. Let's look at the timeline of computer development. So the very first computer, the very first computing machine, was actually found in 2600 BC. It was the Chinese abacus. And the abacus was simply a little device you use to help you carry out mathematical operations. And that was pretty much it. That was the standard for computers for the next 4,000 years until we get to 1910. And in 1910, Henry Babbage constructed part of Charles Babbage's analytical engine. This is actually a mechanical machine that you hand cranked, and then while cranking, it would flip all these switches and actually perform basic mathematical calculations like addition and subtraction. Now that was a 4,000-year difference. Let's jump ahead just 40 years now, and we see that in 1936, Konrad Zuse actually made the Z1, which was the first binary digital computer. So this computer actually used electricity instead of hand cranking with gears, and it used binary as the number system that it did calculations in. So it only uses zeros and ones in the numbers that it represents. And we'll get into more about how this works later, but the binary number system only uses zeros and ones, and this really simplifies things. It makes it so you only have to represent two different digits, 0 and 1. So this was the first binary digital computer. In that same year, 1936, Alan Turing actually came up with the Turing machine theory. And this was actually a huge step forward for theoretical computing. Alan Turing theorized, he didn't actually build this machine, he just came up with this idea of a machine that pretty much could read and write symbols on a strip of paper. So it could remember what it had previously seen by going back and looking at the strip of paper, and it could write out new symbols on the blank parts of the piece of paper. And in doing this, in coming up with this theoretical machine, mathematicians were actually able to answer a lot of questions about the limits of computing. What exactly can be computed by a computing machine and what cannot be computed by a computing machine. So this was the foundation of theoretical computing machines. Fast forward 10 years, 1946, we have the ENIAC, which is the first electronic general-purpose computer. So this computer, instead of being pre-programmed to only compute one specific calculation, it could be reprogrammed to compute whatever calculation you wanted. And this was huge. This is used for the military to compute different trajectories for missiles. And the people who programmed the ENIAC were all women. Women were the first computer programmers programming the ENIAC. In 1950, we had the UNIVAC, which was the first modern computer. So instead of having all these switches that you'd have to turn on and off to program, it actually had a keyboard for input, and it had disk memory as well, so it could remember the computations that it calculated. However, the UNIVAC still took up an entire room. It was this massive computer only used in businesses and government. In 1975 is when we had the first actual portable computer that wasn't stuck in a room. However, it still weighed 55 pounds, it had a tiny 5-inch display screen, and it only had 64 kilobytes of memory. That's less than one song of memory. Now that was 1975. It took 4,000 years to get from the first abacus to Charles Babbage's analytical engine. And in the last 50 years since the portable computer from IBM, we have seen an incredible advancement in computers. We now have iPhones and personal computers and tablets and watches, and computers are in everything that we use today. We've seen such a fast rate of change with computers in terms of their size and how quickly they can carry out operations and what they're being used in. There's actually a law called Moore's Law that applies to this exact concept. So Moore's Law states that the processing speed of a computer, the rate at which it can carry out operations, should double every 2 years as we get better and better at making these processors. And so far, the actual rate of increase has held pretty close to the theoretical rate. It has almost doubled every 2 years. This is an exponential rate of increase. We are getting computers that are smaller and smaller and smaller and faster and faster and faster. In 50 years, who knows what computers will be able to do? So that's a brief timeline of the history of computers. Now, why exactly were people making these computers? Why did they need them? Why don't we just carry out these mathematical calculations by hand? Well, the first uses of computers were really for a couple things. People wanted to keep counts of things like livestock. They were used in marketplaces for things like summing money, so there's no error there. You're having a computer do it. And they were also used to calculate astronomical positions. So if we could predict where the stars would be headed, this is really helpful for things like navigation and calendars. When people started realizing how useful these computers could be, we started really getting behind the development of computers and really putting a lot of effort into making computers faster and smaller. So the uses that were really driving development were to solve math problems faster, and solve more complex types of math problems. There were several military uses, so things like decoding encrypted messages during wars or computing the proper trajectory of missiles. And there's several business uses as well. We wanted to automate the production of goods, and we wanted to keep track of financial data and customer data and all sorts of data. So these are great uses for computers that were driving the development of computers. So now let's take a look at modern computers. We've seen a timeline of the history of computers, but what do computers look like today, and what are we using them for today? Well, you're probably familiar with these modern computers, laptops and desktops and tablets, and these are computers, but these are also computers, phones and smartwatches and toys and cars and simple appliances. Really, computers are pervading our modern life, and they're being put in everything to make them smarter, make them faster, make them better. Really, the only difference between these computers and these computers is the programming. And what do I mean by programming? So a program is a set of instructions written by a human that is given to a computer to tell it what to do. With these computers, these are very general purpose. We can write programs on these computers to have them solve all sorts of problems. Whereas these computers come pre-packaged with a specific program that make them do one simple thing. For example, the coffee maker comes pre-packaged with a program that tells it what to do when a user presses a certain button. The robot pet dog might come with a predefined program that tells it how to react to touch or how to react to light, things like this. So these are all computers. So what are we using these computers for? Well, the answer to that is almost everything. But let's look at a few applications of computers in today's world. So we're using computers for things like autopilot. We're making planes and cars drive themselves. They're used in several medical devices like defibrillators and pacemakers. They're being used in art to create digital art and share art between artists. They're being used to create music, to visualize music, to perform music. They're being used in agriculture to monitor the production of crops and to predict future yields. They're being used in health and medicine to improve the quality of life for many medical patients. It's being used in health and medicine as well to monitor the outbreak of disease and try to prevent huge epidemics. And of course, computers are being used to connect us. Through social media, through messages, through news on the internet, we are more connected today than we ever have been, and that's all thanks to computers. So this is a brief overview of the history of computers. We've come an incredibly long way, all the way from those first very primitive computing machines to the computers today that are connecting us and helping us solve our toughest problems.